I just got back from a vacation to Italy, flying from a direct flight from California to Italy. And when you're in the airplane, they show you the trajectory that the plane is going to take. And I was kind of surprised by it. And I thought it was really cool, and I want to show you what that trajectory looks like. So I'm kind of used to looking at a map like this with California over here and Italy at about the same angle from the equator as California. So under this projection of the map, you might think the flight path was this. The shortest distance between 2 points is a straight line. So if we draw a straight line between California and Italy, we get this line that's almost parallel to the equator. Italy's a little bit farther north, but sort of that's what you might expect the flight path to look at, but then you have to remember we live on a spherical Earth. Now let's look at it on the actual spherical Earth. So we're starting over here in California. So if we fly sort of parallel to the equator along this angle that we have a constant angle from the equator, if we take that path, we see we only get this far. So I have these two green twist ties with two different paths. They're both starting at the same point over here in California, but one's going along one of these longitude lines, and one's going along a diameter. And both of these twist ties have the same length. So if we go over here, this one, doesn't make it to Italy, but this one does. So this was the actual flight path. So look where it goes. It goes leaving California, basically going northwest. We go way over Canada, over the southern tip of Greenland, and then come into Italy. We come into Italy going southwest. So I'll show you what it looked like on the planes monitor. So here's the path along sort of a constant longitude. That's not the flight path. Let me show you on a curved Earth. Now I kind of rotated the globe here to show you what that would look like. So this is a great circle. A great circle is something that has the least curvature. The equator is an example of a great circle. If you put a Matchbox car down on the planet and drove straight, that's the path it would take. Traveling along a longitude line, you actually have to turn to travel along one of those lines. So this shows us, going way over Canada. Like, look how far New York City is from this path. It's nowhere near New York City. It's going over Greenland and coming into Italy, almost along the same direction Italy is going in. So if we go to this thing, look how the plane is coming in. This map isn't oriented with north up, but it's coming in at about a 45-degree line. So let me go back a few. So here's a picture I took of the flight path leaving California and ending up in Italy. Look at that diagonal way up north over Canada. Yeah, big diagonal. So it's not going due east across the country. And then this is the angle. I was thinking maybe it would come in this way into Rome, but it's coming in that way into Rome. And the reason is, when you travel along a great circle, that's the minimum distance between 2 points on a sphere, is traveling along a great circle, not along a longitude line. So we saw the flight path that the plane takes does not travel along constant longitude line, because that has curvature in it. The shortest distance between 2 points on a sphere is called a great circle, and it's if you cut along that path that would go through the center. If you made it like a planar cut through your trajectory, that would go through the center of the Earth and cut the Earth into two equal halves. And traveling along the longitude line does not have that property. You wouldn't get two equal halves. It wouldn't go through the center of the Earth. So there's a big difference between traveling along these constant longitude paths and traveling along a great circle. And so that was how we got to Italy. And then once I got there, I saw this really cool terrain thing that was a really good example of contours. And I saw some glass sculptures that were good examples of 3D contours. So my next video is going to describe what a contour plot is in 2D and 3D and show these cool examples from Italy. Thank you very much.